Today we are starting logarithms. Okay? All we have to decide is what to do with the time we are given. Today we're deciding to do logarithms, because I choose so. Alright, something you need to write down in your journal is how to go from logarithmic form to exponential form. Okay? But first of all, we need to understand what a logarithm is. So what I'd like everybody to do in their graphing calculator is go to y equals and just type a basic exponential function, y equals 2 to the power of x. We're going to make sure your grid lines are turned on and hit zoom and the number 4 so that your graph looks like this. So this graph right here is an exponential function. It's y equals 2 to the power of x. This function has an inverse, and its inverse is a logarithmic function. What do all inverses reflect across from your understanding? They reflect across a line called y equals. So our logarithmic function will reflect across this line y equals x. They will be symmetrical. Okay. So if I have a point right here, then I should have a point that goes right there. All right. They will be perfectly reflected across y equals x. What I want you to do is hit y equals. I'm going to type in the logarithmic function. That is its inverse. So I want you guys right now, this is something you probably want to write down in your journal, alpha, window, number 5. Alpha, window, number 5. The base that we are working in right here, the base that we are working in is base 2. And then you're going to type in an x right here. And you're going to hit graph. Alpha, window, number 5. That's how you can get that in your calculator. Alright? At this point, I want you guys, in your journal, alright, just make it doesn't have to be a perfect sketch. Alright, I'm going to leave this up here. I want you to write y equals 2 to the power of x. I want you to write y equals x. Now that should be an easy line for you to do in your journal. And then this one in black right here. This is y equals log base 2 of x. Right? So these are inverses of each other. And I want you guys to understand this right here is what we're going to be working with today. Alright? We're going to be working in logarithmic form, not exponential form. But you need to know how to go back and forth between the two. Alright, whenever you're learning something new, let's just start with something that you know. Okay? I want you guys to write 2 to the power of 3 equals 8. Right? That's something you should know. 2 times 2 times 2 equals 8. Now, I'm going to highlight the 2 in one color. I'm going to highlight the 3 in a different color. And the 8 in another. Right? This is under the form. Alright? B to the power of x equals y. So right now, my base is b. My exponent is x. And my answer is y. So I'm going to label it. Alright? That's my base. This is my exponent. And this is my answer. 2 to the power of 3 equals 8. Now, in logarithmic form, we're going to write log base b. I'm going to open up parentheses. I'm going to put the y value here and the x value here. Now, understand in the book, they're going to switch the x and the y. If you looked in the book, it's okay. I mean, it's one of those things where in the book they put this. They put b to the y equals x, and then in the book they put log base b to the x equals y. These are both correct. I just have to go with one way. So I'm going with this way. So right now, if I wanted to highlight everything and plug it in exactly where it goes, and I wanted to write this right here in logarithmic form, I'm going to write log, and what number am I going to put right here? If I look at the colors. 2. I'm going to open up a parentheses. What color goes here? I'm going to put in 8, and I'm going to say that is equal to 3. This is what I want you guys to write into your journal as an example of how to go from logarithmic form to exponential or vice versa. So, if I type this in the calculator, log base 2 of 8, and press enter, it's going to equal a 3. If I wanted to evaluate this problem without the use of the calculator, let's say I didn't have a calculator and I wanted to evaluate this, all right? I want to show you guys how to change this to exponential form. I want you to draw an arrow from 2, which is our base, to x, and then draw an arrow from x to the 16. And I want you guys to set it up as this. 2 to the power of x equals 16. So 2 to what power equals 16? Now, something you want to have in your journal, okay? What we're going to do is we are going to write some examples in our journal. I want you guys to start with base 2, which is a very common base. All right, and I want you guys to do base 3, base 4, and base 5. So we're going to write some examples down for base 2, 3, 4, and 5. All right, so we're going to do 2 to the first, 3 to the first, 4 to the first, 5 to the first. All right, squared. We're not going to do all of them, okay? I'm just going to do a few so you can see a pattern. So once you've written down these right here, then I want us to go negative. And if you have these in your journal, then you'll be able to look for patterns. Last but not least, all right, so these are the ones that we're going to do. Everybody, we're going to start right here and understand that any number to the power of 0 is 1. Any number to the power of 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. So these are here's your pattern for base 2. If I say 2 to the negative 1, that becomes a half. 2 to the negative 2 is 1 over 4, and 2 to the negative 3 is 1 over 8. So basically, you guys see the pattern? I got a 1, a 2, a 4, and an 8, and then I have a what? A 1/2, a 1/4, and a 1/8. 3 to the first, 3, 9, 27. What's 3 to the negative 1 going to be? 1/3. What about 3 to the negative 2? 1 over 9, and 3 to the negative 3. Oh, that's 3 to the negative 4. 1 over 27. So if 3 cubed is 27, then 3 to the negative third is 1 over 27. So you can use this pattern to help you guys with your problems. By the way, you're going to have a quiz, and you're not going to be allowed to use your calculators. This is where this is going to come in handy, if you know yours. All right? So we have 4, 16, and 64. So here we're going to have 1 over 4. There you go. If you wanted to build this list on your own, knowing that I'm probably going to use more than just a 1, a 2, or a 3, you could build your own list. All right, I'm just showing you guys how to build it. That's going to be 1 over 5. This is going to be 1 over 25, and this is going to be 1 over 125. Now you can build 6s, 7s, and 8s. Okay, but at some point you can realize we're going to stop. All right. So this is something you need to have in your journal because we're going to be doing this piece without a graphing calculator. We're going to do some rules right now. We're going to go through as many problems as we can on the front page for the first 9 problems. Okay? So you should have this in your journal. All right, we're going to go to problem number 1. Okay? Problem number 1. Without the use of a calculator, this one follows a rule. This is the rule that problem number 1 follows. Log base b of b to the power of x equals x. This is in your basic properties of logarithms. This should be in your notes. Now check this out. If I go through the arrows, b to the power of x equals x. So basically you would write b to the power of x equals b to the power of x. So if I say equals x and I do the exact same thing, what does this say? This says 7 to the power of x equals 7 to the power of 3. So what does x have to equal? 3. That's why if you evaluated this in the graphing calculator, the answer would be 3. What I want you guys to do is be able to change logarithmic form to what? To exponential form. I want you to be able to change those so you can be able to solve them. All right, on problem number 2. What does this mean? What decimal is 001? 0.001. That's 1 over 1,000. 1 over 1,000 is the same as saying 1 over 10 to the power of 3. I want you guys to understand that 10 to the negative third is 1 over 10 to the power of 3. So could you guys rewrite this as log base 10, and right now I'm going to put 10 to the negative 3 equals, just put equals x. So we're going to find out what is, when we evaluate this, what is it going to be equal to? That's right. The more you do this, the more you understand how to rearrange it, the better you're going to get. So right now, what's my base? My base is 10. 10 to the power of x equals 10 to the what? To the negative 3. So what does x have to equal? This has to equal a... What number would have to go in there for these to match? So what are we trying to do? We're trying to get bases that what? Bases that equal each other. That's what we're trying to do. Number 3, put equals x. I want you to change it to exponential form. We're saying 8 to the power of x equals 4,096. 8 to the first is 8. 8 squared is 64. 8 to the third is 512. 8 to the fourth, we'll multiply that by 8. It's going to be 4,096. So 8 to the power of x equals 8 to the power of 4, because that's what 4,096 equals. So what does x have to equal in this particular circumstance? 4. Okay. You need to be able to change things from logarithmic form to exponential form. That's what you're doing on the first 9. I'm going to do one more. gosh. E. By the way, what is E approximately equal to? It's that 2.718 number. Alright? So when you guys see Ln, I want you guys to understand, Ln is what's called a natural log. Alright? So we're going to rewrite this. We're going to say 2. Technically, the natural log is not, it's base E. That's what the natural log is. Anytime you guys have the natural log of E, that will always equal the number 1. If I had 2 log base B, B to the power of x, what does this part right here have to equal? If these are the same, what does this equal? This equals x. Are these the same? So what is this right here by itself? Right there, what does that equal? Five. So that equals a 5. So basically all we have is a 2 times a 5, which is a 10. Now go to your graphing calculator, before you guys head out today. Go to your graphing calculator. I want you to hit Ln, and I want you to type in E. And press enter, and I want you to understand, anytime you have the natural log of E, that's always going to give you a 1. Just remember, Ln is the same as saying log base E. Okay? So the natural log is log base E. So they don't call it log base E, just call it the natural log. We'll continue tomorrow.